Okay, great. So good afternoon, everybody. I'm back. So this is a little bit of a tougher one for 10 minutes, but I'll try than the one in the morning. My name is Arkadiy Shapiro. I'm a product manager at Barefoot Networks, responsible for our core software, the software development environment, and as well the integration with the myriad of the disaggregated switch operating systems. Right? So we're going to talk about some of them, what we've done with them, what we're working on, things like that. Some of them are on display at the show floor doing demos, and I'll try to allude to that as we go on. So real quick, I think probably familiar for you, the whole point of Dataplane Programmability is essentially have the software tell the switch what to do, how to forward packets, how to process them, how to parse them, tell the switch how the tables should be functioning, how they should be sized. And in Barefoot, we believe that programmability should be pervasive and it should be 100% of the switch. Right? So that's why when we do push a P4 program, which in a P4 is a language that's used to describe the switching data plane, it's describing the entire data path of the switch. Right? So when we're talking about disaggregation, of course you have to start with, well, where's my white box? Or a better term is a Barometal switch, right? Because if you talk about some analysts, they use the word white box, bright box, so I like to use the word Barometal switch as a generic term to describe every kind of switch that does not ship with an OS. Right? So today, there are a number of switches. Again, some of them are on display on the show floor. H-Core, WNC are probably the most publicly announced ones that have Tofino-based systems. The Sonic press release that we actually had came out on Tuesday morning mentioning these two platforms as the ones that we've announced the Sonic support for. And there's a bunch of other vendors that some of them are kind of in the works, maybe not as publicly announced, but definitely, if you're looking for a system, you can reach out to them to see what they have and how can you get a hold of it. Right? Definitely, I know on the Inventec side and DNI in their booths, there are Tofino-based white box switches as well. Right? Now, when you're talking about bare metal switch in OS, you have to make sure that the chip vendor does some work to make sure that's onboarded, and also the platform vendor does some work. Right? So we'll talk about most of this in the case of Sonic and also in the case of IP Infusion. Okay. So now, in terms of our software development environment, the bare metal switching OSs, they're using that in order to do the onboarding. Some of them are relying on SCI, and we are supporting SCI, as I talked in the morning through the Sonic session. Essentially, the P4 programs enables all the functionality that SCI and Sonic require, right? Or whichever other OS that may be using SCI, but most of the implementations have been done with Sonic on the SCI side. And then there are other operating systems that don't use SCI, that they just go straight to a lower layer, which we call Switch API. Essentially, Switch API is just representing a higher layer above the P4 program. Right? Now, of course, there's an option for folks to go directly to the P4 APIs, which are also generated. When we talk about things like P4 runtime, that's the case when we're starting to kind of use the P4 APIs directly. Right? And then in the case of P4 program, right, what do these folks typically do? Either they take a reference P4 program provided by us, so we're implementing a P4 program that kind of mimics a fully functional L203 switch with some advanced functionality from Barefoot, or they go write their own program. Or in some cases, what they actually do is they end up modifying the P4 program to add some additional functionality. Right? It just depends on what that operating system vendor is trying to do, what kind of use cases they're trying to fulfill. Right? Okay. So in terms of the bare metal switch operating systems, so what we do in the disaggregated world, I talked about Sonic earlier today. We've announced support for Sonic. We've upstreamed some of the code there in partnership with WNC and H-Core, so the two bare metal switching platforms. IP Infusion is starting to do some work, and they're doing demos in their booth in terms of running on top of the Tofino-based system. Today it's the H-Core wedge system. And I got actually a lot of questions this week about the ONL support. So as of a couple of days ago, I can finally say that we have fully upstreamed everything to ONL based on H-Core systems. Other ones are in progress, but at least folks who are using H-Core, they can grab ONL image from the GitHub and have it fully work on Tofino. Right? So there's no need to kind of get some special patches from us and things like that. So that's, I would say, it's a huge help for the community who are trying to develop kind of solutions on top of the Tofino-based bare metal switches. Okay. And finally, folks have heard an announcement about Project Stratum. So basically the new thin stack switch OS that's based on P4 runtime. So we're starting to do some work in that area. That's probably a little bit earlier down the line because a lot of folks asked about, well, when can I get my hands on it? Can I put it in my data center? So it's probably a little earlier on that. It's in an incubation phase right now. But as they go on, they'll probably start opening it up to more vendors. Right? So as I said, right, different OSs use different APIs. We're trying to adapt, as we see the market evolve. Some folks want to use SCI. I think there was a question earlier about, should you use SCI, should you not use SCI? But there's different choices depending on different OSs and different market requirements. Okay, so quick thing, right? There was an announcement from us in IP Infusion about kind of announcing the support. So essentially, our goal is to marry a very fully functional switch OS that can go into a variety of use cases with a programmable data plane. Right? So once we can leverage kind of a lot of their features, they're also starting to implement things like Dataplane Telemetry, which we're providing to them. Right? And then in terms of Sonic, again, I kind of alluded to this before. The key thing is about it's not just a Sonic support because to bring up Sonic, many folks can do, but to pass through a lot of the community tests, which we've talked about in the earlier BOF, that requires a little bit of work. And again, collaboration between us, Microsoft, our Barometal switch partners, and the rest of the community members to make sure that all these features are working. Our P4 program is provisioned appropriately to support all the Sonic features. Right? So now again, for folks who are doing trying to do a quick start with Sonic, they can just go and grab the image for these two platforms for WNC and HCore, and definitely more is on the way. So don't take this list as kind of like the final list or the only two vendors that we're working with. Right? Okay. Now let's talk about some kind of actual programmability use case. I've been talking about kind of getting started type of topics. The first thing is probably the most common one in terms of Dataplane programmability is supporting emerging protocols. So we've done some demos at SIGCOMM at the last year, talking about segment routing v6. Right? So segment routing v6 is a fairly new technology, so we were able to actually implement it pretty quickly in a data plane and do an interoperability with Cisco that way. Right? So in other cases, I would say PPPoE is not a new protocol, but it's a fairly new thing to do on a kind of a switching ASIC that's data center class. Right? Typically, it's been done kind of like at the other types of products. Right? So we've had a vendor who actually has taken our reference P4 program, modified it, added PPPoE functionality to do like a BNG, BREST type of application on an HCore-based switch. Right? Of course, they have their own switch OS, which was not mentioned there, but that's one kind of other use case where somebody has either taken written a brand new P4 program or has adopted our P4 program to fit their use case. Okay, P4 runtime and kind of things that were announced with Project Stratum is another scenario, particularly talking about next generation of software-defined networking with a very thin stack OS and a controller that's controlling the P4 program and has the ability to actually push a brand new P4 program down to the switch. Right? So we've been working with folks like Google and Onos in terms of trying to advance this project. So the umbrella project for all of this is called Project Stratum, which I mentioned in the previous slide. Right? Other thing, Dataplane Telemetry. So from the two key operating systems in the disaggregated world that we're working with that I mentioned, IP Infusion and Sonic, both of them are starting to support Dataplane Telemetry. So things like in-band network telemetry, all the capabilities we have with kind of deduplication, trigger when we're passing the threshold that I need to send a report, microburst detection. With Sonic, I talked about earlier that we've done the SCI implementation. SCI implementation is now upstreamed. It's part of the master, and I think it's becoming part of SCI 1.3. And we're working on the actual Sonic functionality to make sure that you can actually provision it and don't have to call the SCI APIs directly. Okay? And finally, the programmability of the chips actually allows us to do some other interesting things that are not kind of a typical switch. Right? So we're starting to see a lot of packet broker vendors who've been doing things before with FPGAs or other types of devices that may not have given them as much power and as much performance, investigate a programmable chip for a packet broker use case. Right? And actually build a system, build a packet broker based on the disaggregated hardware, right, based on a switch from, again, H-Core, WNC, and Ventec, DNI, any of those folks, right? So these are some of the capabilities that we're starting to see folks leverage from a programmable chip in order to build a pretty sophisticated packet broker, because these are typically kind of advanced packet broker-like functionalities. Okay, and the last slide is a plug for our P4 app working group. So in the P4 project, or p4.org, which is now part of Open Networking Forum, there was an announcement, I think, last week. There's a working group that kind of discusses and works through all of this kind of new advanced applications. Right? So telemetry is one of them. Anything else that folks want to do with P4 and a programmable chip, usually we have a bunch of vendors that are coming in and discussing and kind of exchanging ideas. Right? Okay, so that's it for today. I'm here for any questions. Thank you very much.
Are you going to take one or two questions real quick before the discussion where we'll be able to ask a lot more?
So on the operating systems, network operating systems, are you going to also support the DNOS one, another open source operating system?
How about now? Yeah. Oh, that's better. OK. So yeah, DNOS, I think we've heard some communication on the DNOS side. We're investigating it. Definitely we have to work with AT&T and the community in terms of how soon and when. I don't have any specific kind of timeline for it. I think it depends on. I think it also depends on the adoption, because right now Sonic, for example, is a very robust community ecosystem. We're not just doing it for any one single customer. We're doing it for a lot of folks, right? So we kind of have to see how DNOS evolves and where would it start fitting relative to everybody else, I would say. Yeah.
Are you with AT&T? No. I was going to say.
Yeah.
Just
it used to be.
Anything else, real quick? OK, thank you.
Cool. Thank you.